My dear students, Namaste. Good morning to you all, and also welcome to another session of our mathematics class. In the previous session, we have completed chapter number 3, that is coordinate geometry. Hope you have revised well. In today's session, we shall discuss a new chapter, that is chapter number 7 from the NCERT textbook, triangles. Let's move on to the topic. I'm sure each one of you knows what a triangle is, but have you ever seen structures in real life which is made of triangles or which uses triangles to form a part or other? Let me show you some such figures. This is a curved dome which has many triangles joined side by side. This is a pyramid of Egypt which has 4 triangular faces. Now try to find out some other examples in your surroundings. Are these triangles shown in figure used only for decorative purpose? The answer is no, and the reason was given by an engineer and architect, Richard Buckminster Fuller. He explained that a triangle, when combined with other identical units, provides solidity, support, and lightweight to a structure. These identical geometrical units use congruent triangles. Have a look at this bridge. It involves many triangles in its construction. The Disney Epcot Center dome is made entirely of triangles which keep it very strong. Now let us go through the chapter to get more knowledge about congruent triangles. Look at these objects. What strikes about them? Yes, they are identical. Let us look at some more identical objects. We will now perform an activity with these objects. First, we draw their outlines and then we remove the objects. Next, we slide the outlines of each pair of identical objects one over the other. What do we observe? The outline at the bottom is invisible and it merges with the outline on the top exactly. Two objects identical in their shapes and size are said to be congruent to each other. Exact correspondence of two objects in shape and size is called congruence. This is the symbol of congruence. Here are two line segments PQ and ST. We will check if they are congruent. The line segments are congruent as their lengths are the same. It is also true that if two lines are congruent, then they are equal in length. Here are two angles, angle AOB and angle PQR. Let us find out if they are congruent. The angles are congruent as their measures are the same. It is also true that if two angles are congruent, then they are equal in measure. We have already discussed the term congruent. Congruent means same size and same shape. We have also discussed congruency in case of lines and also in case of angles. Two lines are said to be congruent if they are equal in length, and also if two angles congruent means they are equal in measure. Next, we shall discuss congruency in triangles. In a pair of triangles, if all three corresponding sides and three corresponding angles are exactly equal, then the triangles are said to be congruent. Here, the term or the word corresponding sides and corresponding angles has its own significance that we will discuss later on. If you consider a pair of triangles, means two triangles, if you consider, there are 6 parts, means 3 sides and 3 angles. Consider a triangle ABC and another triangle DEF. corresponding sides in the sense, if you take AB in triangle ABC, if you take side AB in triangle ABC, the corresponding side of DEF is DE. And if you take AC in first triangle, the corresponding side is DF. And if you take BC in first triangle, the corresponding side is EF. And also, if you consider angle A in first triangle, the corresponding angle in second triangle is D. And B corresponds to angle E, and angle C corresponds to angle F. So these two triangles congruent means their corresponding sides and corresponding angles must be equal. First, let us consider the sides. Corresponding sides means AB must be equal to DE, then AC must be equal to DF, and BC must be equal to EF. So here three sides in first triangle are respectively equal to the corresponding sides of the second triangle DEF. Then if you consider angle A must be equal to angle D, and angle B must be equal to angle E, and angle C must be equal to angle F. Here the correspondence or the corresponding sides, if you take AB corresponds to DE. Here AB corresponds to the second triangle, if you consider, that is DE. Next is BC. The second triangle, first triangle, if you consider BC, the corresponding side in second triangle is EF. That is BC corresponds to EF and AC corresponds to DF. And in case of angles, A corresponds to D. Angle A corresponds to angle D. Then angle B corresponds to angle E. And finally, angle C corresponds to angle F. So here three sides are respectively equal to the corresponding three sides of another triangle, and three angles of first triangle are respectively equal to the corresponding three angles of second triangle. Then we can say that triangle ABC is congruent to triangle DEF. This symbol, this means congruent. Triangle ABC is congruent to triangle DEF. We must note that in congruent triangles, the corresponding parts are equal and are written as CPCT. Means if you take two triangles and if they are congruent, means their corresponding parts are equal and the corresponding parts are represented by a short form CPCT. Meaning is, abbreviation is corresponding part of congruent triangle. C stands for corresponding, P stands for parts, C for congruent, T for triangle. Next point is, if two triangles ABC and PQR are congruent under the correspondence, A corresponds to P, means if you consider angle A in first triangle, corresponding angle in second triangle is P, B corresponds to Q and C corresponds to R. Then symbolically it is expressed as triangle ABC is congruent to triangle PQR. Here position of each vertex is important. Here first vertex is A, and in the second triangle corresponding angle of the first triangle, that is corresponding angle of first triangle, here we have taken A, the corresponding angle is in the second triangle P. Here we have written A corresponds to P. Then second angle we have taken, or second vertex is B. B corresponds to Q. That means in the second triangle we have to write Q, and C corresponds to R. So triangle ABC corresponds to triangle PQR. You should not change the order of ABC. Any one order you should not change, because when you change the corresponding sides order, it will be changed. So that will be a wrong concept. So you must write as, if A corresponds to P, B corresponds to Q and C corresponds to R, means we have to write triangle ABC is congruent to triangle PQR. We have already discussed the congruency of triangles. If two triangles are congruent, means their corresponding sides and angles must be equal. Means three sides and three angles must be equal. Means we have to compare total 6 elements. For checking the congruency of triangles, it is not necessarily check all these 6 elements. There are some criteria for checking the congruency of triangles. Next, we shall discuss the criteria for congruency of triangles. The first criteria is SSS criteria for congruency. Here S stands for side. SSS means side, side, side. Means we have to compare only the sides, three sides of one triangle and three sides of another triangle. The statement says if three sides of one triangle are respectively equal to the three sides of another triangle, then the two triangles are congruent. In first triangle, we have to consider three sides, and that three sides must be equal to the corresponding three sides of another triangle, then the triangles are congruent. In short, if you say three sides of one triangle must be respectively equal to three sides of another triangle. Consider a triangle LMN and ABC. Let's compare or let's consider the corresponding sides. Here LM is 3 centimeter and AB is also 3 centimeter. So LM corresponds to AB, means LM is equal to AB. Then LN is 7 centimeter, length of AC is also 7 centimeter, means we can say that the side LN is equal to side AC. The third side MN is 5 centimeter and here BC is also 5 centimeter. So we can say that MN is equal to BC. Here three sides of first triangle are respectively equal to the three sides of the second triangle ABC. Here LM is equal to AB, LN is equal to AC and MN is equal to BC. Then we can say that these two triangles are congruent. Here we considered only three sides. Since we are using here three sides, that is called SSS congruency criterion. Side, side, side. We are taking only the three sides of one triangle and comparing it with three sides of another triangle. Next, we shall discuss SAS criteria for congruency. If two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of other triangle, then the two triangles are congruent. Here, two sides and the included angle of one triangle must be equal to the corresponding two sides and the included angle of other triangle, then the two triangles are congruent. Here there are two terms which we need to give importance. The first one is included angle and the second one is corresponding. The word corresponding we have already learned. Next we shall discuss included angle. Here two sides and one angle is same and the angle is included between the sides. Two sides in the sense S and S and the angle is in the middle. So here S stands for side, A stands for angle and S stands for again side. And since the angle is between the sides, then we can say that it is an included angle. So angle must be between the sides. If you summarize the statement, two sides of and included angle of one triangle are respectively equal to the two sides and the included angle of another triangle, then we can say that they are congruent by using SIS criteria. Let's visualize it. Here there are two triangles, one is triangle ABC and another one is triangle PQR. Here if you check AB 2 centimeter, PQ is also 2 centimeter, means AB is equal to PQ. Again BC marked 4 centimeter and QR marked 4 centimeter. Means we can say that BC is equal to QR. And here very important one is the angle, and the angle B and the angle Q are 50 degree each. And here the angle is marked in between the two given sides. AB and BC, in between AB and BC angle B is there. And here in between PQ and QR angle Q is there. So the included angle is here B and Q and included angles are equal, that is angle B is equal to angle Q. So two sides and the included angle are respectively equal to the two sides and the included angle of another triangle. That's why we can say that these two triangles are congruent. Move on to the third criteria of congruency of triangles, that is ASA criteria for congruency. Here A stands for angle, S stands for side, and again A stands for angle, and the side is included between the angles. Let's go for the definition. If two angles and the included side of one triangle are respectively equal to two angles and the included side of other triangle, then the two triangles are congruent. As I mentioned before, two angles and the included side means side is in between the angles. So two angles and the included side of one triangle are respectively equal to two angles and the included side of other triangle, then the two triangles are congruent. Here ASA means A stands for angle, then S stands for side, and again A stands for angle. And the side is in between the angle, that's why this is called included side. Then, if you summarize, two angles and the included side of one triangle are respectively equal to two sides and included angle of another triangle, then we can say that the two triangles are congruent. Let's go for visualizing it. Here there are two triangles XYZ and PQR. Here angle Y and angle Q are equal, they are 60° each. Angle Z and angle R are equal, they are marked 45° each. And the included side means between these given angles Y and Z, the side is there, that is YZ. Here between the given angles Q and R, the side QR is there. So the included side YZ and QR are also equal. Therefore, we can say that these two triangles are congruent by using ASA criterion. Next, we shall recall the concept of hypotenuse of a right angle triangle. As we all know that the right angle triangle means one angle must be equal to 90°. And the term hypotenuse means the side which is opposite to the 90° angle. Here 90° angle is this one. The side which is opposite to 90°, that is this side, that is called the hypotenuse of a right triangle. And please note that hypotenuse is the longest side of a right angle triangle. If you consider a right angle triangle, there are three sides, and among these three sides, the longest side must be the hypotenuse. And once again, hypotenuse means the side which is opposite to the 90° angle. Next, we shall discuss the fourth criteria for congruency of triangles, that is RHS criteria for congruency. Here, if in two triangles, hypotenuse and one side of a triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. Here, this criteria is used only for right triangles, and we have already learned what a hypotenuse is. Hypotenuse means the longest side of a right angle triangle which is opposite to the 90° angle. Here, if you consider two right triangles, hypotenuse and one side of a triangle, hypotenuse and one side of a right triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. Here RHS means R stands for right angle, H stands for hypotenuse, and S stands for side. Means in a right triangle, hypotenuse and one side are respectively equal to the hypotenuse and other side of another right triangle. Then we can say that the two right angle triangles are congruent by using RHS criterion. If you summarize, hypotenuse of and a side of one triangle are respectively equal to the hypotenuse and a side of another triangle, then the two triangles are congruent. Let's visualize it. Consider a right angle triangle ABC. AB is marked 3 cm and AC is marked 5 cm. Another triangle PQR, that is also right angle triangle, and PQ is marked 3 cm, PR is marked 5 cm. Here the first case, that is right angle triangle. So both triangle ABC and PQR are right angle triangle, and we have to compare the hypotenuse. So here hypotenuse AC is 5 centimeter, hypotenuse PR also 5 centimeter. Hypotenuse means 90 degree opposite side. Here angle B is 90 degree, opposite side is AC, and here angle Q is 90 degree, opposite side is PR. So AC is equal to PR. And third one is side. Here the side AB and PQ are equal. AB is 3 centimeter and PQ also 3 centimeter. So by using RHS criterion, we can say that these two triangles are congruent. Next, we shall discuss some properties of triangles. A triangle in which two sides are equal is called an isosceles triangle. This we have already learned in the smaller classes. Isosceles triangle means two sides must be equal. Here triangle ABC is given to you. The length of AB and the length of side AC are equal, that is 3.5 centimeter, and BC is having another length, that is 5 centimeter. When you observe triangle ABC, here two sides AB and AC are equal in length, that is 3.5 centimeter each. Therefore, we can say that triangle ABC is an isosceles triangle with AB equal to AC. Two sides are equal. Next property is angles opposite to equal sides of an isosceles triangle are equal. This is a very important property. Angles opposite to equal sides. Here there are two sides AB and AC. Here when you check AB, the opposite angle is C, and when you check AC, the opposite angle is B. Means these two angles are equal. Angles opposite to equal sides. Here AB and AC are equal sides. Angle opposite to AB is C. Angle opposite to AC is B. So here angle B is equal to angle C. The next one is the sides opposite to equal angles of a triangle are equal. The reverse statement of the previous one. The sides opposite to equal angles of a triangle are equal. Here triangle ABC is given to you and two angles are marked, that is angle B and angle C. Angle B is equal to 50 degree and angle C is also 50 degree. So angle B is equal to angle C. The sides opposite to equal angles means here C, if you take the side opposite to C is AB, and if you consider B, the side opposite to B is AC. Means here AB and AC are equal. So AC is equal to AB. Each angle of an equilateral triangle is of 60 degree. This also we have learned before. Each angle of an equilateral triangle is of 60 degree. Equilateral triangle means all three sides are equal. Three sides equal means three angles also must be equal. And three angles equal in the sense, by using angle sum property, the sum of the angles in a triangle is 180 degree. So if you divide 180 with the three angles equally means each angle will get 60. So 60 into 3 is 180. So each angle of an equilateral triangle is of 60 degree. Hope it is clear. As per the syllabus, we have to learn the proof of a statement which we have discussed before. Next is the proof of that particular statement. Prove that the angles opposite to equal sides of a triangle are equal. Once again, prove that the angles opposite to equal sides of a triangle are equal. Here, given condition is a triangle ABC and two sides AB and AC are equal. Let's draw the triangle. That is triangle ABC is given to you and two sides AB and AC are equal. And what we have to prove is angles opposite to equal sides. We have already discussed this one. Angles opposite equal side in the sense equal sides are AB and AC. The angles opposite equal side in the sense if you take AC, the angle opposite AC is B. And if you consider AB, the angle opposite to AB is C. That means we have to prove angle B is equal to angle C. That is mentioned here. There is a construction part here. Draw a bisector of angle A intersecting BC at D. We have to draw the bisector of angle A. Bisector in the sense we know that a line segment which divides the angle into two equal parts. So the bisector of angle A in the sense Whenever this line comes into this triangle, the line divides angle A into two equal pieces. That's why it is called bisector of angle A, and it intersects BC at D. Come to the proof. There are two triangles, a triangle BAD and a triangle CAD. Here there is a triangle BAD. When you draw a line segment AD, the entire triangle ABC is dividing into two triangles. One is triangle triangle BAD, and another one is triangle CAD. So the corresponding parts you have to be careful. BAD and triangle CAD. When you consider these two triangles, by using the similarity criterions, we have to prove that these two triangles are congruent. Let's go for proving the congruency. AB and AC are equal. In the first triangle there is AB, and in the second triangle there is AC. So side AB and side AC are equal. That is our given condition. Next one is angle BAD and angle CAD are equal. BAD and CAD are equal. This is because of our construction, because we have drawn AD, the bisector of angle A. That's why angle BAD and angle CAD are equal. The next one is AD equal to AD. When you consider these two triangles, that is triangle BAD and triangle CAD, if you consider, there is a common side for both the two triangles, that is AD. So AD equal to AD, that is common for both the triangles. Then here when you check two sides and the included angle, here there are two sides, one is AB, another one is AD. Another two sides if you consider AC and AD, they are equal, and the included angle in the sense angle BAD and angle CAD, here these two included angle are also equal. So these two triangles are congruent. Triangle BAD is congruent to triangle CAD by using SAS rule. So side angle is in between the side, or included angle we will say. So if two triangles are congruent means their angles, their corresponding parts are equal. CPCT, by using CPCT, corresponding parts of congruent triangles, we can say that their corresponding parts are equal. Means angle ABD and angle ACD are the corresponding angles of the two triangles BAD and CAD. So angle ABD equal to angle ACD. Here angle ABD in the sense it is angle B, and ACD in the sense it is angle C. So we can say that angle B is equal to angle C. That is what we have to prove. Hence the proof. Means we can say that the angles opposite to equal sides of a triangle are equal. So this statement or the proof of this theorem is very important. So please go through it. My dear students, today we have discussed all the basic concepts from the chapter triangles. Please go through each and every point which is discussed in the video, and if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.